The topic of our presentation today is iterator design pattern. So let's first answer what is an iterator. An iterator is the collection of algorithms or the logics that you need to traverse a particular collection data type. These include your stacks, queues, lists, arrays, and trees. So the collection data types are those that can hold multiple values under the same name. The main thing an iterator design pattern does is it hides the underlying complex representation of data and how it is placed in the memory. So like if you take a look at a list, let's say it holds 5 entries. Those 5 entries are never in consecutive order, rather they are spread apart in the memories in different locations, just pointing to each other. So what iterator does, it translates this complex pointing to one another to just next and previous entry. So there is a current location, there is an entry after that, and an entry after that. So in this successive uses of next, you can basically look at every single variable or entry of a data type. This is what an iterator basically does. Now that we have talked about what an iterator is, let's talk about why we needed iterator design patterns. So firstly, the collection data types, we talked about the arrays, the lists, the queues, etc. Those are the most commonly used data types in programming. So naturally something that lets you take further advantage or makes them easier to use is greatly important. At the same time, iterator design pattern, since it has multiple different algorithms that are independent of each other, it allows you to traverse a single array or a single data type to multiple different points. So if you have two iterators of the same array going on, each of them can traverse independent of each other. One can basically be reading the third entry and the other can be reading the fifth entry. So this is a very huge benefit, you can say. Also, since all of the iterators have like this similar working, so it has like go to next, go to previous, is there a next, is there a previous, this kind of logic. So it really helps with the readability of the code. Also, it helps that the programmers don't really have to hard code everything, since you can dynamically go to the next and the previous. So the iterative design pattern is like a really useful, you can say, design pattern.
Assalamu alaikum. My name is Asif, and today I will present to you what is a structure iterator. So, a structure iterator is a behavioral design pattern used to transfer elements of a collection without exposing the underlying representation. And now I will explain the components in the diagram. Number one component is client. The client interacts with the collections and iterators. It requests the iterator from the collection and uses it to transfer the collection elements. So number two point is interface iterator. This is an interface that defines the methods for accessing and transversing elements. Typically, it includes methods like get next or has more. Get next suggests which will be the next element in the collection. Has more, it will check if there are more elements to iterate over. The third component is interface iteratable collection. So this interface defines a method for creating an iterator object. It typically includes creator iterator function. This method runs an instance of an iterator for the collection. And the next will be a concrete iterator. This class implements the iterator interface. It maintains the current positions in the transversal of the collection. It has the following attributes: collection and iteration state. Collection is a reference to the collection being iterated over, and iteration state the current position within the collection. And the methods include concrete iterator, constructor, which is constructor that initializes the iterator with the specified collection. Get next retrieves the next element in the collection. Has more function check if there are more elements in to iterate over. Concrete collection. This class implements the iterable collection interface. It represents a concrete collection that can be iterated over. It includes methods like concrete iterator returns an iterator for the collection. So now I will explain how it works. The client requests an iterator from a concrete collection by calling create iterator. The concrete collection returns an instance of concrete iterator. The client uses a concrete iterator to transfer the elements in the concrete collection. The concrete iterator keeps track of the current position and provides access to the elements sequentially to each get next and has more methods. Now I will explain the functions which are used in the iterator, in the code of the iterator. The first function is has next. This method check if there are more elements in the collection. It returns true if there's at least one more element, and false if the iterator has reached the end of the collection. Next, this method returns the next element in the collection. If there are no more elements, then calling next throws a no such element exception. Remove. This method removes the last element that was returned by next. It can only be called once per call to next. And the final is remove. This method removes the last element that was returned by next. It can only be called once per call to next. For each remaining consumer, there is more recent addition to the iterator interface, and it allows you to perform an action on all the remaining elements in the collection using a lambda expression or a method reference.
Okay, so first of all, the first two lines are importing libraries that the code will use. For example, the array list is used to create the list that can grow in size, and iterator is used to go through the elements of the list one by one. Okay, so second one is main class and method. So we will talk about in this the main class. This is the main class of program. Inside it, the main method is defined, which is the entry point of program. When you run the program, the code inside the main method is executed first. Okay, so number third is creating the array list. So this line in the code will create the array list named car that will store strings. So fourth point is adding element to the array list. So in this lines of code, we will add four car brands named to the cars list. Okay, and fifth one is creating the iterator. Okay, so in these lines of code, create the iterator named it for the cars list. The iterator will help us go through each element in the list. Okay, so iterating through the list. So the block of the code does so this block of code does the following. The code is while into it dot has next function. So the has next method, this is a has next is a method, and it checks if there are more elements in the list to go through. It returns true if there are more elements and false if there are none left. Okay. Okay, so now we will talk about the pros and cons of the iterator. So first one is you can clean up and the client code and the collection by extracting bulky traversal algorithms into space classes. In this we are talking about cleaning up the client code and collecting the extra bulky traversal. So second point is you can implement new types of collections and iterator and pass them to the existing code without breaking anything. So we can very easily add new iterators and collections without making any significant changes to the code or breaking the lines of code. So third one is you can iterate about the same collection in parallel because each iterator object contains its own iteration state. Okay. Next point is for the same reason you can delay an iteration and continue it when needed. So this point relate to the third point which we just talked. So fifth point is you can clean up the client code and the collections by extracting bulky traversal algorithm into separate classes. So how we can clean up the client code and this is done by extracting bulky traversal algorithms into separate classes. So we should have to make the separate classes for this. Next point is you can implement new types of collections and iterators and pass them to existing code without breaking anything. as we talked before, that we can very easily edit and change the code and make new changes, adding code, all the things without making significant changes to the code or breaking the lines of code. So next point is you can iterate over the same collection in parallel because each iterator object contains its own iteration state. And the last point is for the same reason you can delay an iteration and continue it when needed. So as the same reason as we talked, like you can iterate over the same collection in parallel. So this is also the same reason that we can delay an iteration and continue whenever we want. Okay, thanks.